So question 2 says solve the following logarithmic equation. So on this one, we can do many things. What I pick up on to start with is this coefficient can come back in as an exponent. Also see addition, which means I can write this as a single logarithm. So let's see if we can start using some strategies to solve this problem. And there's a lot of ways to solve equations. This is not the only way to do it. You may experiment with other things, because one thing to also pick up on is the log of 9 base 3 is actually 2, because 3 to the power gives me 9 would be 2. So there's a lot of things we can pick up on here as we see this. But the first thing I'm seeing is this 2 can come back inside as an exponent. So the log of x minus 4 squared base 3 can be that. Plus then, yeah, and I can actually write this log of 9 base 3 as a 2 is equal to then this 4. So what I can actually do is move this 2 to the other side of the equation. So the log of x minus 4 squared base 3 is equal to 2. Now, the strategy I would use here, since there's only one logarithm involved, I would go for exponential form. So remember, if I have x equals a to the y, that's going to be y equals the log of x base a. So notice how I have a logarithm, but notice how this a is the base and this y is an exponent. So notice how this 3 is a base and this 2 is an exponent, because it's kind of flip-flop, but it's still very similar. So if I want to rewrite that like this, you'd have the log of x base a is equal to y. But notice how the a and the y go together. So this 3 and 2 can go together. So this 3 squared comes together, and then the x minus 4 squared becomes the x part. So it comes to form the other side of the equation. So the x minus 4 squared becomes that part. So notice how the 3 is the a, the 2 is the y. They create one side of the equation, and then this x minus 4 squared is the x part. So what I have now is a quadratic equation. So I have x minus 4 squared equals 9. Now, we haven't done these type, but we can go ahead and just take the square root of both sides. In doing so, this becomes x minus 4. And when you take the square root of 9, that's going to be a 3. But remember, this has got to be a plus or minus 3. There's two solutions here. So yeah, you can use the inverse operation of squaring, which is the square root. But you got to do that to both sides. But remember, since this is squared over here, this part here could be a positive or a negative number. So we have to have this plus or minus 3. So I can now make this equation look easy by just moving the 4 over. X equals 4 plus or minus 3. So 4 plus 3 is 7. 4 minus 3 would be 1. So there are two solutions, 7 and 1. Now, do we have any domain restrictions to pay attention to? Notice that we do have this x minus 4 here. So this x minus 4 has to be greater than 0. So x has got to be greater than 4. So what I'm picking up on, we would have to probably exclude the 1. So let's see if it plays out by actually just verifying it. If we put a 1 in the problem, does it actually work? So 2, again, this is a base 3 log, so math. So if I put a 3 here in, if I do 1 minus 4, plus then that's actually a 2. Does it give me 4? notice how it gives me an error. So they are saying that 1 has to be excluded. It would not make this problem work because of that domain restriction there. So the solution set becomes then just the 7. So we have to watch out for domain restrictions because you gotta take the log of something greater than 0. So what makes x minus 4 greater than 0? Well, you have to be 4 or bigger. Actually, bigger than 4, because if you pick a 4, that's going to make that 0, and you can't take the log of 0. So the 1 does get excluded out of that problem that does crash that question. So 7 is the only solution.